Okay, here I have a pendulum, and I'm going to let it swing back and forth, and it's swinging back and forth with a certain frequency. Okay, the frequency is going to be defined to be the number of cycles done in a unit of time. Now I'm going to use a unit of time, the minute as a unit of time. So I want to know how many cycles this thing goes through in a minute. Now a cycle is from here to here and back. And as it turns out, and you can verify this, I'm going to shorten this thing a little bit, my arm's getting tired. As you can verify later, or anytime if you want to make a pendulum, and you really should do that, the period doesn't depend a lot on the amplitude of the swing. Amplitude being how far the pendulum goes from here to here. Well, actually, I take that back. Here's the equilibrium position. If I can get a hold of the thing, I'm looking at the camera. Here's the equilibrium position. Amplitude is how far I pull it back from equilibrium position, or how far it swings out from the equilibrium position. Now, as it continues to swing, the amplitude is going to decrease. But that isn't going to significantly affect how long it takes the pendulum to go back and forth. It is not going to significantly affect the frequency. Okay, so if I want the frequency, and if I want to use the minute as my time interval, I'm going to then count this for a minute. And I'll count like so. 1, 2, 3, 4, 5. Now I start the count here. So I could say start 1, 2, 3, 4. Okay? Now I notice that if I hold the pendulum a little closer to the mass, to the washer in this case, the frequency, does it increase or decrease? Okay? Well, if I count it for a minute, what am I going to get? Am I going to get more counts here, or am I going to get more counts here? The answer should be clear. The frequency increases as the length decreases. So as the length increases, the frequency decreases. Now, in actually counting the pendulum, I can count half cycles. I could count 1, 2, 3, 4, 5, 6 for a minute and divide that by 2, and I would have an answer that's probably accurate to about within a half cycle. I could even get really fancy and count. Okay, let's go. Let's see. Release 1, 2. Okay, let's get the rhythm. Okay. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, 1 is hitting here, 2 is hitting here, 3, 4. Okay, or maybe had 1 here, I don't remember now. Okay, but I think it was release 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And at the end of a minute, you know what number you're on, so you could actually count it to the quarter of a cycle. Now, I will observe that people are pretty bad, especially the groups that I see of high school age are really quite bad at counting accurately. Don't seem to be able to count 50 to 100 cycles or half cycles accurately. If you have 20 different people count the same pendulum, holding it in front of them for a minute, you might get counts for a pendulum of this length that could vary anywhere from 40 to 70, and it could anywhere in between. People with musical training are a little better at that, but people get distracted. They lose track of, is this the 20s or the 30s? I don't know exactly what happens, but the results are uniformly terrible. So you might think about how to count the pendulum accurately and what strategies you might use. And really, that's kind of okay. I mean, it would be good if people could count the pendulum accurately, but since people aren't counting it accurately, it gives us some noise in our data that we're going to get when we do a graph of frequency versus length. Excuse me. And will allow us to consider uncertainties in measurement, which always exist. If we had perfect counts, we'd have very little uncertainty in the measurements, and we wouldn't be able to analyze the uncertainty. So In a way, that's not such a bad thing, but really people should be able to count a little more accurately. So that's something you might want to work on. Okay, so you really ought to make your own pendulum. Now what we're going to do is we're going to measure the length of a pendulum. We're going to count it for a minute and see how many cycles there are. And we're going to record the length and the number of cycles. Then we're going to measure a pendulum, maybe a shorter one. Do the same thing, going to measure the length. And when we measure the length, okay, it's best if you make your own pendulum to use a ring or a washer or something of that nature that's uniform in shape. Okay, uniform around a center, circular uniformity, circular symmetry. And if you use a ring with a stone in it, it's okay. Just be sure the stone is here and not here. Okay, now if you do that, then you measure the length of the pendulum from the center, okay, from right there in the very center up to where you're holding it. And you hold it between two fingernails so there's not much uncertainty in how long the pendulum is. Okay. Crap. Gonna have to, didn't start the other camera, gonna have to do